Okay, as I said before, there is a very easy and fast alternative. If you follow my suggestions, creating an Excel file with the data, it will make your life easier and make the thing faster. And one solution is if you go to Excel, to your file, to Excel file, I have here the loads and I have the values for P and Q, and it's the same order that I have inside the DIgSILENT PowerFactory, okay? You must be careful that the order that you have here is the same that is inside PowerFactory, because otherwise you will make a very crazy and very bad mistake, okay? Right now I select, let's go to the loads, and let's go to Power Flow, and now paste. And voila, we have right now all the loads done in just few seconds, okay? Next step, let's do something similar for the reactive uh, capacitance that they are using for voltage control, okay? If you have been following my steps, you must have the names of all the the shown reactants in order, and you can see over here QC1, 2, 3, 4, 5, 6, 7, okay? And there is a basic data here that we need to complete. And as you can see, one of the data that we need here is the voltage, nominal voltage for those capacitors, okay? What I will do again is my suggestion going to my Excel file, and right now go to show data, and the first data that I will take here is the voltage. However, be sure that the order is the proper order, 1, 2, 3, 4, 5, 6, 7. Now you can go back to PowerFactory, and in this column for the nominal voltage, you can input here the rate voltage of those capacitance. Next step, we need here the data of this reactive power, okay? And what we need to do is again going to the Excel file. Let's go to the Excel file. And there is a column here with the AVAR. And let me copy and go back to PowerFactory. And right now what we will do is paste here. Okay, let me see. We need to paste here, reactive power C. Where is the reactive power C? Oh, it's here. And right now we have here the reactive power C in every single capacitor, okay? Right now we have done with the loads. The loads are there. We have finished the data for the capacitors. And what we need to do now is let's go for the transmission lines, okay? For transmission line, we can use a similar approach. For transmission line, we can do the similar approach. However, we need to do one more step, okay? Transmission lines, they are quite interesting devices because the transmission lines, they require that we define a type, okay? And what I suggest to all of you is basically define the step here following create a new line type, and we can call this L. This is the line between 2 and 3, and the nominal voltage of this transmission line, is 500 kV, and then we need to put the resistance and the reactance, okay? What I will do is something very simple. Right now, if you look over here, we have the transmission lines, and the only transmission line that is having this kind of type is the transmission line 2 and 3. Okay, as I said before, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 transmission lines, okay? At the moment, we have only one transmission line that is having the type, and we are missing 1, 2, 3, 4, 5 more. And what we need to do is duplicate this object, the transmission line type, in order to make easier the data completion here. What I will do is a magic trick here. I will go to the data manager. I will go inside the project, and inside the project there is something called the library, and inside the library they are the type, equipment type. And what I will do is the following: copy, and then I will create a bit more. 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay? And right now we have here, we have only one because we are using only one, but we can do the following. Select project type, select project type, then select project type, then select project type, then select project type, and finally I think we have missing one of them. Okay, right now let me check the transmission lines. And if you go here, we have, let's see, okay, this must be line 13. This must be line 15. This must be line 23. Line 23. This must be line 25. This must be line 46. And then this must be 67. Let me check the names. Okay, we have here to change this one. Oh, what is happening here? What is happening here? Okay. I believe I know what is the problem, but we can survive in this way, okay? Right now, if we check the transmission lines, this one is wrong. This should be 1, 3. 1, 5, 2, 3, 2, and this should be 6, 7. Okay. Okay, right now we have line 1, 3, line 1, 5, 2, 3, 2, 5, 4, 6, 6, 7. Yes, we are done here. And right now, what I need to check is the types. We have type 1.3, 1.5, 2.3, 2.5, 2.7. And let me check the following. Let me check the order. I will copy this and I will go to my Excel file at the moment. Okay, let me check the names. No, this is not working because these are, let me go to the transmission lines. Yes, this is the place that I want to go. Okay, let me go back to PowerFactory, copy the names, going back to Excel. Let me paste the name to check if everything is fine. And the line's name, let me check the line names. 67, 46, 25, 23, 15, 13. Okay, the names are perfectly fine. Now what I will copy is the nominal voltage. Go back to PowerFactory. And right now we have the proper voltage, and now we need the resistance and the reactance. This line should be 60 here. Okay. Then we need the resistance and the reactance. And we go to Excel right now. This is ohms. And this one is ohms also. Okay, right now what we need to do is copy this and go into PowerFactory and paste. Yes, right now we have here all the resistance and the reactance, and they are inside the proper transmission line together with the proper nominal voltage. Yes, and there are only few things missing. Okay, there are only few things missing. One of the things that we need to do is right now we need to define this transformer, and this transformer require a new project type, and this will be the transformer TRX power 1060 here. The high voltage side should be 765, and the low voltage should be it should be 500 kV, and in this case is 3.9%. Okay, let me check the connectivity. High voltage is bus bar number 6. Let me see. High voltage is bus bar number 6. Yes, it's 7. And low voltage is this bus bar, and this is 500. Yes, the transformer is properly connected. The last step, and probably the most crucial here, the most important one here, is to define types for the generators. Okay. In this case, what I will do is the following. Okay. What I will do is I will go to the generator number one, and new project type. It will be 1000. And as you must remember, those generators, they are connected directly to the high voltage bus bar. In this case is 500 kV. Okay, and this is the generator type G1. Okay, what I will do is this generator have a type, but this one not. We need 1, 2, 3, 4 more types. Okay, again I will go inside the library, and here we have a generator, and I will paste 1, 2, 3, 4, 5, And in order to avoid any mistake, this will be generator 2. This will be dedicated for generator 3. This one will be dedicated for generator 4. This one for generator number 5. And let me see, there is one more generator, generator 6. Okay, let me see. In this case, this is okay. Let me go back to the system and check how many generators do we have here. We have 1, 2, 3, 4, 5, 6. We have 5 generators, and this one require a type. Select the project type, and this will be generator number 2. Perfect. And this should be generator number 3. Perfect. And this one should be generator number 4. Generator number 4. And there is one more missing, and this is generator number 7. Let me change the name. This will be generator number 7. And we will use for this generator number 7, okay? Okay, right now we have all the generators. We have all the generators here, G1, 2, 3, 4, 7. And then we have here the types, okay? What we need to do is put the proper data of these generators, okay? Generator number 2 is 500, generator number 3 is 500, but generator number 4 is 765, and generator number 7 is 665. And then what I need to check is the following, okay? Generator number 1 is 500, 2 500, 3 400, and then 765, done, okay? Now I need to define the operational conditions, and what I will do is go to load flow, okay? Generator number 1 is a PV system, and the active power should be this is a PV, must be 1.03, and the active power of this generator should be and again, having a Excel file will be easier for us for completing the data. And right now we have the complete the data for the generator number 1, okay? Something that I need that you realize is that, okay, we have the power dispatch for those generators, okay? For the generator 1 is this number over here, but we need to define several things. For instance, the power of the other generators. And what I will do here is I will copy this and I will go back here and paste, okay? And something that you must be aware is that the generator 1 is all of them are working as all of them are working a constant V mode, and the reference machine, the swing machine, is the generator number 7, okay? And in this case, generator number 4, let me check the power of generator number 4. Yes, generator number 4 look like 6,500, okay?